Good day, guys. We are meeting today for questions. I believe that we've been taking series in the previous classes, and last class we were able to talk about reactions. We're doing a lot about reactions. Now we are now going to be looking at some questions on all what we've done so far. So we're looking for ways to give better explanations to things we've done before. So we have questions, a lot of them, and we'll be using that to touch each concept we talked about before. For the first question there, you said a basic postulate of the kinetic theory of gases is that the molecule of a gas move in straight line. That is true. I recall when you're talking about the postulate of gases, you said that gases move in a straight line. It moves in a straight line. And what are the reasons why? Maybe that's what the president tells us. So move in a straight line between collisions. This implies that now we know that fine, we have molecules of gases. Consider a reaction medium here. A reaction medium. We believe that these particles of gas do not exert either attractive or repulsive force. We talk about that. That's not the postulate of them. They do not exert either attractive or repulsive force. That is, they do not attract each other or repel each other. Then we are now seeing again, force of repulsion exists. No. So, but what are the reasons why? We recall again that when these particles collide, we observe that the collisions are inelastic. Is it inelastic or elastic? You can see the question options there. They're now trying to test us on what is the answer. And the answer is collisions are what? Elastic. Why is it elastic? Because energy is conserved. Energy is conserved. Energy is conserved. Energy is conserved. When energy is conserved, you can see that the collisions are elastic. And that is what happened in a system of gas. The next question then, if a gas occupies a container of volume 146 centimeter cube, now I want to solve some questions. So please follow us. I want to solve some questions. It says, if a gas occupies a container of volume, the volume V1 is equals to 146 centimeter cube. At T1 is equal to 18 degrees Celsius. Please, gentlemen, once we see 18 degrees Celsius, don't wait, convert. What do you convert it? 18 plus 273, we convert it to what? We convert it to Kelvin, and that is 291 Kelvin. And the pressure given to us is 0.971 atm. Is volume on CMP, so V2 is the unknown. At STP, let's recall at STP, what happens? P1 is 1 atm, and T2 is 1 atm, and T2 is 273 Kelvin. At STP, very important, at STP, and what is STP? Standard temperature and pressure. So V1, T1, P1. Now we can recall that P1 V1 over T1 is equals to P2 V2 over T2. Making V2 instead the formula, then we have V2 is equals to P1 V1 T2 over T1 P2. Now what is your P1 here? Your P1 is 0.971 times your V1 is 146 and your T2 is 273. What is your T1? The T1 is 291 and your P2 is 1 atm. I can get my calculator to quickly solve that. So when using a calculator, you need to be very, very fast. So I'm guessing 133 centimeter cube. Let's check the option to know if we are right. Let's check. Yes, that is option A. Option A tells us 133 centimeter cube. Question 3. If 10.8 grams of silver is deposited in a silver colorimeter connected in series with a copper colorimeter. The volume of oxygen liberated is dash. We believe that oxygen is liberated where silver is deposited. So we need to know what volume of oxygen is what is liberated. Guys, ladies and gentlemen, we need to understand something. And we need to first know the equation that is involved here. The equation. First of all, silver. Silver is Ag plus electron, giving us Ag. And from the question given to us, we're given the mass of silver as 10.8. The mass of silver as 10.8. So mass of silver is what? 10.8 gram. Now, the ones that shows the deposition, the liberation of oxygen gas is what? 4OH giving us O2 plus 2H2O plus 4 electron. Plus 4 electron. From here, you can calculate the amount of oxygen liberated. 4 electron here means 4 Faraday. 4 Faraday gives us 1 mole of O2. Now, we now need to know if 4 Faraday gives us 1 mole of O2 and also giving us 22.4 dm cube. 22.4 dm cube. Now, we don't know the mole of O2. We don't know the mole of O2, but we're given the mass of silver and we can do relationship. So let's get the it should be 0.1. That is 0.1 mole. So knowing that the mole of O2 will give us the 2.4 dm cube will be what? So therefore, I can calculate that 4 Faraday will be equals to 22.4. So I want to do the relationship of between the volume and mole. Between the volume and mole. So knowing that, let me clean the board. So want to know the amount of volume that will be in that Faraday. In that Faraday. So let's first determine, we want to determine the number of moles that will be in that Faraday. So let's solve for that. So we know that we've gotten the number of moles in silver as 0.1 mole. Now we want to now determine the amount of the volume in the Faraday. So we know that for 4 Faraday equals to 1 mole of O2 equals to 22.4 dm cube at STP. At STP. So doing this, you do 0.1 mole of this and you get y. So y will be equal to 0.1 times 72.4. That gives us 2.24 dm. 2.24 dm. Now let's go, please look at it very, very well. And let's see what we feel might be the right answer. Now, guys, if you look at this question now, what we are solving here is in the answer. That means if we are right, you should see your answer in the option, and you might be wrong too, and see your answer in the option too. And that is what I want to try to bring out here. That we might be correct and we might be wrong. They will now have to sit down and let's think on what will be the right approach to the question. Now, guys, I'm going to check the unit and look at it now. DM cube mole. Now, if you look at this, asterisk this, come back to this. Next question there. Question 4. Question 4. We are not told you are given that in the reaction CR to O72 minus CR to O72 minus plus 6Fe2 plus 14H plus giving us 2Cr3 plus 6Fe3 plus 7H2O. Now, you're not told that why is the chromium change? The chromium change from year to year. Now, first of all, let's calculate the oxidation number of chromium here, and that is Cr to O72 minus. That is 2 chromium plus oxygen is -2. -2 times 7 equals to -2. -2 here is the net charge of that ion. That is 2Cr minus 14 is equal to -2. And 2Cr is equal to -2 plus 14. You can say 2Cr is equal to 10 and 12, and Cr is equal to plus 12 over 6. Chromium here is 2 times plus that is what it is. So we can say clearly that it moves that they have the chromium change from the chromium itself is changing, even because of let's not balance it yet. We're not balancing it yet. There's no chromium changes from +6 to +3. So it's when you balance it that it now becomes balanced. So on a normal day, when you are getting this equation itself, it's always from +6 to +3. Why? Because in the half reaction, you have Cr to 170 minus giving you Cr2 plus. That is +6 +3. The next question, question 5. It said iron is galvanized. Iron is galvanized. Iron is galvanized with zinc cathodically. But then conclusion, this is because so I say iron is galvanized with zinc cathodically. But then from corrosion, this is because the reason why, because I said earlier on that we have what we call sacrificial ions, metals that help us in what? In protecting a delicate metal. For example, now, the reason why iron is galvanized with zinc is because of the fact that if you look at iron, you look at the potential of iron and the potential of zinc, you observe something that you observe the fact that zinc oxidizes before iron. Zinc oxidizes before iron, and that will help in protecting the iron from what? From rusting. So because of the fact that zinc oxidizes before iron, zinc will have to what? Wear out first before iron can get rusted. And the next thing we need to also consider here is the option. They also said what will be the in terms of the oxidation potential, what will it be? The reason why is because zinc has less positive oxidation potential than iron. Therefore, we can conclude that zinc will oxidize first. Zinc will oxidize first. Next question. Question 6. Which of the examples will react faster with dilute triosonitrate 5 acid? Now, I'm not talking about rate of reaction. We talk about the nature of the reactant. And we learned that every reactant do not react at the same rate. And we learned about the fact that the nature of the reactant can affect the rate of reaction. I remember when we talked about we use the lumps and powder. Sorry, we use granular and powder. Now we are looking at this. Which of them will react faster with dilute? So you have 5 grams of lump, 5 grams of powder CaCO3 at 25 degrees Celsius, 5 grams of powder CaCO3 at 50 degrees Celsius. Now, you have to first establish something. That powder and lump, powder react better than lump. The question is now why? Why? Because powder has what they call an increase in the surface area. An increase in the surface area. So therefore, it reacts better than lumps. Then when I look at the temperature there, if you observe, you have 25 degrees Celsius, you have 50 degrees Celsius. Now, we now recall that an increase in temperature will increase reaction rate. So therefore, you have 25 degrees Celsius and 50. Look at option B and D. So option B is 25, option D is 50 degrees Celsius. So we pick what? Option D. Because we believe that at higher temperature, there will be an increase in the reaction rate. Next, the question 7. A sample of gas exerts a pressure of 8.2 atm. Pressure is 8.2 atm. When confined in a volume is 2.93 bm cube. Our temperature is 20 degrees Celsius. Now, when you are always learn to what? To convert from 20 degrees Celsius to Kelvin. You have to convert from Celsius to Kelvin. That is very, very important. So from Celsius to Kelvin, that is plus 273. That will give us 293 Kelvin. 293 Kelvin. So we are looking for the number of moles. We don't know it, but we recall ideal gas equation. PV is equal to nRT. Making sense of the formula here, N is equal to PV over RT. Ladies and gentlemen, we need to know what R is. What is R? R is gas constant. If R is gas constant, we need to know what R are we going to be using. Let's look at the data here. This is ATM for pressure, volume is in dm cube. Guys, we have to use R is equal to 0.0821 atm dm cube mole per Kelvin, and not R is equal to 8.314 joules per mole per Kelvin. Why? Because these are dimensionally units. Look at the unit. It works with it, but this is called the standard R, where all the parameters are in the standard unit. We can solve for N 8.2 times 2.93 over 0.082. You're even giving the R set too. And your temperature is 293. We can solve. 8.2 times 2.93. 293 times 0.08. And the answer is 1. N is 1. 1 more. N is 1 more. N is 1 more. Option A. N is 1 more. Question 8. Now, which you are given an equation. Very nice question. MnO4 minus plus 8He plus Ne minus, giving us Mn2 plus 4H2. Guys, we need to balance this electron. But first, we do what they call net charge. This is -1 and this is +8. So -1 plus 8. Let's add them together. We get +7. So +7, the net charge on the right-hand side is +2. So I have to make it balance. So in order to do that, I have to add electrons to the left-hand side. And I have to add 5 electrons. So N here will be equal to 5. When I do that, we have +2 on the left hand side and +2 on the right hand side. Question 9. Which of the following is a measure of the average kinetic energy of the molecules of a substance? I remember taking this like this. In postulate, the answer is temperature. We believe that kinetic energy is directly proportional to what? Temperature. So as temperature increases, what happens to kinetic energy? It also what? Increases. So you need to understand that basic concept. Question 10. Very good question. Now you're asked here, to what temperature must the gas 273 Kelvin be heated in order to double both its volume and pressure? Very nice question. So let's write our data. Let's write our data quickly. So it said to what the right is T1 is T1. T1 is 273 Kelvin. P1 is unknown. P1 unknown. But P2 and V2 were doubled. That is 2P1, 2V1. But T2 is the unknown. We can recall our what? Gas equation. Gas equation. That is P1 V1 over T1 is equal to P2 V2 over T2. And what is your, let's make T2 formula here, T2. So T2 be equals to T1 P2 V2 over P1 V1. And what is your T1? 273 times 2P1 times 2V1 over P1 V1. Go away. So 2 times 2 is 4. 273 times 4, that should give us 1092 Kelvin. And that is the answer to that question. That is question 10. Question 11. What volume of oxygen will remain after reacting 8 cm³ of hydrogen with 20 cm³ of oxygen? Wow. We recall our Gay-Lussac's law and our Avogadro's number. And we recall, when we are talking about Avogadro's number, we're talking about the fact that number of moles is the same with what? With the volume of the gas. Number of moles is the same with the volume of the gas. And that is one thing to say about that, about Avogadro's law. And we need to apply that. So we need to also apply that in this question here. So with this question here, we need to apply it now. So let's apply something like that. Now, what volume of oxygen will remain after reacting NCM? First of all, we need to first give a balanced chemical equation. A balanced chemical equation between hydrogen and oxygen to give us H2O. Balance. Now I believe it's balanced. We said what volume of oxygen will remain after reacting 8 cm³ of hydrogen with 20 cm³ of oxygen. But what you can see here, you can say that 2 volume, 1 volume, and 2 volume. 2 volume, 1 volume, and 2 volume. So if I'm going to be reacting 8 cm³, what will be X? X here, if I'm reacting 8 cm³, O2 should be 4 cm³. O2 should be 4 cm³. Or, now, we can choose to react this or this. But let's see the implication of everything there. Let's see the implication of everything there. So I use it. 4 will be here. And if I do that, you need to be very sure of what you are trying to do or trying to accomplish. The third, what volume of hydrogen will remain after reacting 8 cm³ of hydrogen with, so that means you are reacting the amount of hydrogen here with oxygen. So I'm going to be reacting 8 cm³ of hydrogen. I'm going to be reacting 8 cm³ of hydrogen. That means X here, oxygen will be what? 4 cm³. And here will also be what? 8 cm³. Removing that, that will be 20 minus 40. That is what? 16 cm. The answer to that question is D. Option D. Option D. The next question, we have 2FeCl, 2 solid, plus Cl2. They give us 2FeCl3. And I'm not told to determine the reducing agent in the reaction above. You know for here, how do we know the reducing agent? How do we know the oxidizing agent? Once again, how do you know the reducing agent? And how do you know the oxidizing agent? Let's brainstorm on this. Let's brainstorm on this. Let's brainstorm on this. If you observe, we are having FeCl2 and Cl2. One which of them is the reducing agent. First of all, we need to know which of them undergoes reduction and oxidation. Reduction and oxidation. Let's analyze them. Chlorine here is 0. Chlorine here, FeCl2. This is like you saying chlorine is what? -3. -3. FeCl2 and Cl2. Ion here is +2. Ion here is +3 in terms of ion. They can conclude that an increase in oxidation number is called what? Oxidation. So from FeCl2 to FeCl3 is called oxidation. That means this FeCl2 was oxidized. It was oxidized, and therefore it is the reducing agent. Reducing agent. That is how we can easily detect or identify oxidizing and reducing agent. Now, knowing that, we'll take a pause. So we can come back to that aesthetic question. Let's take a pause and we'll really come back to that aesthetic question and let's see. Let everybody try to go through it and attempt it. Now, I want to try this question again. The number of moles of silver, we are given the mass of silver as 10.8 grams. Number of moles is equal to mass over molar mass. Over molar mass. Now, the mass here is 10.8 over 128. This is telling us 0.1 mole. Now, we can recall that 4OH minus is giving us O2 plus 2H2O plus 2 plus 4 electrons. Now, you can see clearly that we have only 1 mole of oxygen gas here. Only 1 mole. Only 1 mole. And the fact that we have only 1 mole, we recall that 4 Faraday is 22.4 dm³ equals to 1 mole of O2, 1 mole of O2 gas. And therefore, knowing that we need to first of all get the number of Faraday. Get the number of Faraday. In doing that, get the number of mole rather. So in doing that, I have to do 32.4 over 4. And 32.4 divided by 4 is 5.6. That is 5.6 dm³. So in 1 Faraday, we have 5.6 dm³ of O2. And what will now be with respect to silver? Since we are saying that 1 mole of silver of O2 is equal to this, then this volume that we have, then see the volume with respect to silver. To get the volume of O2, we have to multiply 5.6 by 0.1. That's 0.56. The answer is not 0.24, but this is the right answer. This is the right answer in terms of what? Of the volume of O2. In terms of the volume of O2. So guys, this will be the end of the class. So we meet next class where we'll be talking about important topics like energy. Very important topic in chemistry, where you know that you will not miss in the exam. Energy. We'll look at the exothermic reaction. I remember when I talking about rate of reaction, I give an assignment on exothermic and endothermic reaction. And I'm going to take everybody back to that part where we talk about energy changes. So guys, thanks for your time. Do have a nice time.